personal finance practice problem using Excel. Present value and future value mathematical formulas problem number 2. Get ready because finance is getting personal with personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're in the practice tab down here as opposed to the example tab. The example tab in essence being an answer key. We have the information on the left-hand side, going to populate that into the blue area on the right-hand side. But before we do, we want to take a look at what we have done thus far. Note that you don't need to go through or have done the prior problems to work this component, but we want to see how the multiple calculations can fit together. We also want to look at how to maneuver in our Excel worksheet, noting here, which is probably the case on your worksheet, that we have some hidden tabs or hidden columns to the left because we're starting at column O. So I'm going to practice unhiding the columns so we can see what we've done prior to this by putting my cursor on column O and then dragging over to the left to go to that triangle, letting go, right click on the selected area, and then I'm going to say unhide, and there we have it. Now I can put my cursor back down. I'm hitting the left arrow so I could go all the way back. It still didn't do it. I'm going to try it again. It only unhid one column. I want it to unhide all the columns. Right click, unhide. So there, I think it did it. Now I'm going to put my cursor down, go all the way to the left. Here we are in column A, where we have the information. The information will be the same for multiple formats. That is, the yearly earnings percent of an investment are 12%. Then we said, how long will it take for the investment to double? We did that with the rule of 72, basically taking 72 divided by 12. That gives us an approximation of 6. We did our running balance calculation so that we can see the actual interest as it accumulates upward. We then did the future value, present value, and number of periods functions in Excel, which is probably the easiest way to do the calculations in practice. And now we're going to take a look at the format with regards to the calculations for a formula to do these calculations. We have a similar type of problem as we did when we did our functions over here as we look at the formulas, in that we will typically be looking at the present value and future value formulas when we're considering formulas. Note that in practice, most of the time you'll probably be using Excel functions and running balance type of tables, but in a course, you're probably going to look at the formula, and of course the formula can help you to see the relationship between the present value and future value. So we're going to use the present value and future value formula to figure out the number of periods, which is once again kind of the unknown that's within the formula. Realize that if you look up the answer to some question like this in a book problem, they will probably rework the formula, as we saw kind of here in the function section, to be solving for the number of periods. But in practice, what you would most likely do is plug in the information either to the present value or future value formula, solve for the unknown, which will be the number of periods, and that's how we'll format it here. So now I'm going to go back and I'm going to hide the cells again so that we can get back to where we were in practice, hiding the cells so I can just see column O and to the right. And you don't need to do this, but I think it's good practice to do. So I'm going to put my cursor on this little skinny column, which is the N column, left click, drag all the way to column A, let go, right click on the selected area and hide it. And so now we're just working with the information from column O to the right. Now we have our calculations for the present value. Here's the formula. Here's the formula for the future value. So the present value formula can be formatted as present value equals the future value. And you could think about that as future value as the numerator, because times 1 over, or future value as the numerator over 1 plus R, which is the rate, to N, which is going to be the number of periods. Now, obviously, we can just simply plug our information into that formula because what we have up top is the rate. So we know what the rate is. We know what the investment is, which we're going to assume to be 2,000. If they didn't give you the rate, then, and they're trying to get the number of periods, then you can basically pick a number like 1,000 or 2,000 or 100 or something like that to work through a problem if it asks you to double it and you want to use a formula method to do so. And then we've got to the number of periods, which is the unknown, and that's what we would then solve for. So if we were to do this algebraically, it would look something like this. We know what the present value is. That's going to be 2,000. That's going to be equal to the future value, which I'm going to just say over future value would be the 2,000 times 2 because we want it to double, or 4,000 divided by, and it would be 1 plus r, which was the 0.12 or 12%. And then we're going to take that to the caret of the number of periods n, which is our unknown. And then, of course, we can solve for n using our algebra, reworking the equation to basically solve for that n number, given it's the only unknown. I'm not going to do the algebra for us here, but rather I'm going to put this into the table in this format and then use our kind of trial and error method to do the goal seek, because I think that's useful to build a table, and it's also useful to basically think about how the goal seek will work with an equation that we can kind of see how to work algebraically, so that if we were to use functions or something like that, we could see how to apply the same concept. So I'm basically going to take this formula and I'm put this into a table, which you can think of kind of like a tax return type of format, which is often useful to do basically in practice. If you were doing a test question, then you would, of course, use the algebra with a paper and pencil. If you're in practice, you're often going to be using spreadsheets, and I would highly recommend using spreadsheets more and more often when you can. Building tables can be useful. If I was going to put this formula into a table format, I would try to get the numerator and the denominator on the outer column and any more subcategory calculations in the inner columns. This is also how financial statements will kind of be built. So you can use the same types of conventions when building this out as you would when building basically a financial statement. So we'll start with the future value, which is basically the numerator. So I'm going to say future value. We know that number because it's going to be twice what the investment is of 2,000, so it's going to be 4,000. I'm not going to type in 4,000, however. I'm going to say equals and pull our data from the data set, because that's just our good practice to do, times 2. There's going to be our 4,000. Then we're going to pick up a subcategory, which I'm going to label, and we could just label it basically as the denominator, but I'm going to label it as 1 plus r to the n. And I'm going to put a colon indicating that this is going to be something that we're going to pull into the inner column and then subcategorize it outside once we finish the calculation. So I'm going to say 1, and then the rate is going to be this 12% up top. So I'm not going to type in 0.12, but rather say equals and point to the 12%. I'll call it the rate over here. That's going to be the rate. And then this is at 0 because we don't have it in a percentage format. So we're going to go up top to the home tab numbers group. We could add decimals to make it more 0.12, or we could make it a percent, moving the decimal over 2 places and adding a percent sign. Then we're going to go to the font group and underline it. And so there we have that. And that's going to give us our 1 plus r, I'll call it. We'll say that's the 1 plus r component. And brackets, and I'm going to add those up. Now you could just say add them up like the 1 plus the 12%, and also note that you might see this 1 as a percent. If I was to format this as a percent, it would of course be numbers group format percent, 100% plus the 12%, which is going to give us 112%. So I could use the trusty sum function, most common function that you really should and must know, and that's going to be the sum, by far the most popular and function in Excel. So there we have it. Now I'm going to add that. I'm going to go to the home tab numbers group. You could make it a decimal, which would be 1.12, or if you make that a percent, that would be 112%. And then we're going to take to the number of periods. So I'm going to n, which periods. And the number of periods is our unknown. We don't know what that is. I'm going to put that down here as just picking a number. So I'm going to say just 5 down here. And then I'm going to use that number in our equation and use basically the goal seek feature to then fix that number to what it needs to be to make our end result correct, and see how to use the goal seek function in that way. So we're going to say equals the 5 down here. I'm going to make that yellow. Home tab font group, making it yellow so that we can indicate that that's the thing that we're going to be adjusting later. And then that's going to be our total here, which we could just call the denominator, but I'm going to say 1 plus the r to the caret shift 6 n periods, and I'm going to put that in the outer column, and this is going to be the 112 to the caret, of 5, power of 5. So this is going to be equal to the 112. The way you go to the power of is say shift 6 or the caret and then the 5. So S6 caret S7 and enter. There we have it. I'm going to add some decimals here by going to the home tab number group, add some decimals, which I call decimalizing it, which isn't, again, it's not a real word. You probably don't want to use that in a professional setting, but I kind of like saying it. It's been decimalized. In any case, it could have more decimals than that. I'm going to underline the 5 here, home tab, font group, and underline. And that's going to give us our present value, bottom line number down here, present value, which is now the numerator and the denominator are in the outer column, so we can just divide them out because that's what we do with numerators and denominators. So we're going to take the num or numerator divided by the denom or denominator, and that's going to give us our 2270. Now, we know what this end result it should be 2,000 because we said we were going to be at 4,000, the doubling point. We want to bring it back to the starting point, which we know is going to be the 2,000. So we could then adjust this. We could say, well, what if I adjust my number down here to kind of figure that out? So we're using our algebraic concept, which is basically saying if there's only one unknown in this series of numbers, I know what the end results would be, but there's only one component I don't know, then I can figure out what that is. But instead of doing so by reworking the equation to solve for that component algebraically, I want to use the goal seek, which is quite useful, especially when you're looking at a much more complex table situation or one in which functions are used. So we could then say, okay, well, what if this was like 6? What if this was 7? And so on and so forth like that. Or we can use the goal seek function. So I'm going to click off the cell. I'm going to go to the data tab up top. We're going to go to the forecast and say do our what if analysis. What if? Then we're going to go to the goal seek. And we got the dialog box. And that's basically going to say, okay, Excel, we would like you to set this cell to be by going to this cell here and taking it to what we know it should be, which is the end result of 2,000. Make that 2,000, please. And do so by changing then this cell with the 7 in it. So take this cell to whatever it needs to be to make that end result what we know it should be, which is 2,000. We're going to say OK. And so there it gives us that 6.12. 6.12, and we're going to say OK. Let's add a couple decimals up top, making that a bit more exact here. Add a couple decimals, and there we have it. Okay, so now I'm just going to format it a little bit. So this indentation, I'm going to select these columns underneath it. And so I'm going to select and show that these are basically a subcategory by going to the Home tab, Alignment, Indent them. So it's shown by the colon. It's shown by them bringing it into the inside and now being indented. So it's redundant, but it's kind of useful and nicer to see. And then this one brings it back to the outside. So I'm going to go up Home tab, Alignment, and Indent there. That kind of shows that it's going to be pulled over to the outside. Let's put an underline under this one. Home tab, Font Group, Underline. We could do a double underline here if we want to be fancy. Home tab, font group, and then double underline, the double D on that one. Okay, so then let's do this again using the future value so we can get to the same answer using the future value, giving us an idea of the relationship between these formulas. So let's go on over to the future value, same scenario. We got the future value equals the present value times 1 plus r to the n. So if I was to do that algebraically, we got all the data we need here because the future value is twice the starting point. So that would be 4,000, which would be equal to the present value, which is where the starting point is, 2,000, and then that would be times this time instead of a division problem, brackets 1 plus r, which is going to be the 0.12, brackets to the caret of shift 6 n. And that would be the unknown n. Then we can solve for it algebraically. So that's one method we could use. That's what you would do in a book problem most likely. But we're going to build this table out once again and then think about our goal seek function, the table being a useful thing to be able to build. Goal seek, a good tool, especially with more complex problems. So we got the future value equals the present value times 1 plus r. So I want this and this to kind of be in my outer column. That's what I'm visualizing the table to be. Any other subcategories such as this, I'm going to put inside in the inner column and represent that as a subcalculation. So we got the present values going to be the starting point here. Put that right in the outer column. That's the starting point of the 2,000. I'm not going to type in 2,000, but rather say equals, point to that 2,000. There we have it. Then we're going to say that we want 1 plus r to the n, which is the other half here, the other half we're working with. I'm going to make a colon after it, indicating that this is going to be a sub-calculation that we're going to pull into the inner column. I'm just going to say 1, and then the R is going to be the rate, and the rate I'm going to say is equal to the 12%. I'm not just going to type it in or hard code it as they say, but point to W2 cell, add some decimals by going to the home tab number. We can add some decimals, 0.12, or see it as a percent number group, percentifying it. That's what I call it, percentifying it. That's not a real word, but I kind of like the ring of it. I like the sound. I like the sound of the percentified. It's been percentified. So in any case, home tab, font group, and then we're going to go to the drop down. We're going to put an underline here, and then this is going to be the 1 plus the rate, which we'll call it. And so I'm going to sum that up, and notice this, you can think of this as 100%, this 1, right? 1 plus R. So you can home tab number, if I made that a percent, it would be 100%. We can add this up, equals the SUM. 100% plus 12% is 112%, showing 1 until we format this thing. Home tab number, adding some decimals would make it 1.12, or if we move the decimal 2 places to the right and add a percent, percentifying it, as I would call it, but no one else does, but I think it sounds good, it would be 112%. So then we got 2n periods, and bracket that. So it's going to go to the number of periods. This is what we do not know. So I'm just going to pick a number down here. Let's just pick like 3, just to have a number to be working with. And then I'm going to go back up top and just say this is going to be equal to that 3. That's the number we're going to change. I'm going to make it yellow to indicate that's the varying component. Home tab, font group, yellowfied it. Then font group and underline it. And then this is going to be the brackets, 1 plus the rate, and then close it up, shift 6, caret, n, periods. This is going to be in the outer column, so I'm taking the 112% to the 3 periods, to the power of 3, cubed, as they say. So this is going to be equal to the 112%, shift 6, caret, to the 3, to the power of 3, and then enter. Now we're going to make that a percent by going to the home tab number, or we could just add decimals or percentify it. I'm going to add a lot of decimals. This is when decimalizing comes in, because there's a lot of decimals. You just add as many as you can just to get a good feel for it, knowing that the decimals still keep on going in Excel. Whenever no matter how many calculations or how many decimal points you show, Excel will calculate based on the actual number that's in there. So even if you're only showing 1 or 1.4, it's really calculating 1.404928. You got to know that, or you'll get frustrated with rounding. So then we're going to say, here we have this. We're going to multiply out the outer column, because we got these two sides now. Outer column, that is the 2,000 times the 1.404928, and that's going to give us the 2810. So we'll use our algebraic concept once again, knowing that this end result needs to be 4,000, because we're getting to the future value, which is the 2,000 times 2, or 4,000. And we want to get there by changing the component of 3 up top, the number of periods. So you could do that with trial and error instead of reworking it algebraically down here and say, well, what if I put 4 here? What if I put 5? And so on and so forth. Or you can ask Excel to do that. So let's do that using the goal seek feature by going to the data tab up top, going to the forecast, going to the what if analysis. What if? Let's do some what if analyzing with the goal seek. We want to say, we're going to ask Excel, because we're polite. We like to ask Excel, would you set that cell to be 4,000? Because we know it should be 4,000 by changing this cell down here. Would you possibly be able to perform that for us? It would be so nice if you would. And Excel's like, yeah, I can do that. And there it is. There's the 4,000. They changed this to the 6.12. We're going to say, okay. And then we're going to go to the home tab up top. Font group, let's just do some formatting here. This is indicating that it's indented again. So I'm going to indicate that as well by selecting these tabs and indent it by going to the home tab, alignment, indent there. And then I'll go to this last one down here and indent that again by going to the home tab, alignment, indent again. So there we have our 6.12 and the 6.12 that we saw last time, kind of give it an idea of the future value and present value calculations similar to each other. We did similar things with the tables or we did similar things with the functions. Next time, we'll take a look at how we can use tables to basically do a similar type of thing as well. So that'll be exciting. Make sure to return for that.